Hi, and welcome to Fatima Explains, where I make learning simple and make complex topics easier to understand. So today we're going to learn about amino acid structures. And here's a basic structure for amino acid. We have a central alpha carbon that is attached to a carboxyl group, an amino group, a hydrogen group, and a side chain. Now remember that this side chain differs for each amino acid. And I'm just gonna write AA for amino acid. And to remember their structures, first we need to learn their names. And to remember their names, we have a little mnemonic here: Gavlump, PTT, Stag C, Lahag. And whatever's at this bottom line over here, that's just the one letter abbreviations that differs from the mnemonics first letters. What I mean by this is, for example, glycine over here is represented by the letter G itself in Gavlump. However, phenylalanine, the first letter abbreviation is F and not P. That's what I've written in the second line over here. Okay, so let's go back to the structure of our amino acid. Here, we have a backbone that's going to stay the same for each amino acid, and then we have a side chain that's going to differ for every amino acid. And now we're going to look through the structure of each amino acid. We'll just follow this mnemonic over here, and here this is the mnemonic expanded, so we're just going to follow along with this list to easily remember the structures. So first we have our non-polar amino acids. The first one is glycine. And for glycine, the side chain is just going to be H. And since the side chain is just a hydrogen atom, glycine is the smallest amino acid. Next we have alanine, which just has a methyl group as a side chain, so CH3. Then we have valine, which would have 3 methyl groups, and so we have CH, CH3, and then another CH3 that's branched. And if you look closely, it forms a V shape for valine. So let me just point that out. It's like a inverted V shape. For leucine, what we're gonna do is we're just gonna copy the side chain for valine, and then at the top of this chain, we're just gonna add another methyl group, and there we have leucine. Next, we have isoleucine. For isoleucine, we're gonna copy the chain that we had for leucine, so the previous side chain, and then what we're gonna change here is this methyl group that's branched right over here, and then we're just gonna move it one up. And there you go, there you have our isoleucine. And another thing that we change over here is the number of hydrogen atoms attached to each carbon. So remember that carbon has to make 4 bonds, and in this case the first carbon would have 4 bonds, the second would have 4 bonds as well, therefore it would have 2H. Next we have methionine. So again, we're gonna follow the same pattern. We're gonna take the side chain of the previous amino acid isoleucine, bring it over to methionine, and what we're gonna change here is we're gonna take this branched methyl group and we're gonna bring it to the very bottom and branch it with the last carbon in the chain. And then what we're gonna do is we're gonna remove this carbon here and we're gonna place a sulfur instead. So remember, methionine has a sulfur atom. Next we have proline, which makes a ring structure with its backbone. And here I'll show you how it makes that ring structure. So basically, the side chain would connect the alpha carbon of the backbone with the amino group using 3 carbons. Next we have phenylalanine, which has a ring structure that's benzene ring, comes from the name phenyl, and it's an aromatic amino acid. That's why it has a ring structure. So we're just gonna attach a methyl group with the benzene ring, and that's gonna be the side chain for phenylalanine. Next, tryptophan has a double ring structure in its side chain. So we're going to take the phenylalanine side chain and copy it to the tryptophan. But remember, the benzene ring is not directly attached to the methyl group in this case. Rather, what's attached to the methyl group is a pentyl group that's cyclic in structure, and it has a nitrogen atom as well and a double bond. So that gives you your double ring for tryptophan. Next, we have our polar amino acids, which are uncharged. So first we have tyrosine. And remember, tyrosine is also aromatic. And the reason it's polar, it's because it has a hydroxyl or an OH group in its side chain. So the tyrosine side chain is really simple. It's essentially the same as phenylalanine with the methyl group and a benzene ring. The only difference is that it has an OH group at the end. Then we have serine, which also has an OH group that makes it polar, but it does not have a ring structure. So it's not an aromatic amino acid. So what we're going to do here is we're going to copy the previous amino acid side chain again. And since serine is not aromatic, we're going to remove the benzene ring and join the OH with the methyl group. Next, we have threonine, and it also has an OH group that makes it polar. For threonine, again, we're going to copy the side chain from serine, and we're just going to add a methyl group that's branched. Next, moving on to our next amino acids, we have asparagine and glutamine, which has C double bond O NH2 group at the bottom of their side chains. So for asparagine, we'll just go with the methyl group and then add the C double bond O NH2 group at the bottom. For glutamine, it's the same thing, except that we're going to add another methyl group at the top of this chain. Next, we have cysteine, which has a sulfur in it, and so we're just going to simply have a methyl group attached to SH. Next, we have our polar charged amino acid. Remember, bases are positive because they have an amino group attached to its side chain, and acids have a carboxyl group in the side chain, which makes them negative. So acids have a C double bond O minus group, and bases would have NH3 plus or double bond NH2 plus to make them positive. Moving on to lysine, it's going to have the same side chain as glutamine, except this time we're not going to have the C double bond O. We're just going to replace it with 2 methyl groups. So in total, lysine would have 4 methyl groups and an NH3 plus at the bottom. Remember, nitrogen usually makes 3 bonds, but in this case, it would make 4 bonds to make it positive. Next, we have arginine. It's going to have the same side chain as the previous amino acid, but what's different here is that arginine has 3 nitrogen atoms. So what we're going to do here is it has 3 nitrogen atoms attached to the very last carbon of the arginine group. So that would be carbon 4. So we're just going to move this down a little bit, add another nitrogen atom in this chain, and let me remove the hydrogen atoms here. And we're going to add a 3rd nitrogen that's branched with this carbon. Now let's make sure that one of the nitrogens is positive. It's going to make a double bond and would have 2 hydrogen atoms, making 4 bonds in total. That makes it a positive, and therefore that's a basic amino acid. Next, we have histidine. So histidine has a methyl group attached to a cyclopentane with 2 nitrogen atoms and 2 double bonds. And in this case, both of the nitrogen atoms would make 3 bonds. This is because the pKa of histidine is really close to the physiological pH of our body, and therefore when the pH of the body goes below the pKa of histidine, it would exist as in the protonated form. Therefore, it's still a basic amino acid. Next, we have aspartic acid. And remember, it has to have the C double bond O minus in its side chain. So aspartic acid is really simple. We're just going to have a methyl group attached to a carbonyl group. Next, we have glutamic acid. It's going to have the same side chain as aspartic acid, but we're just going to add another methyl group at the top. There you have your 20 amino acids, including charged, uncharged polar amino acids, and non-polar amino acids. Thanks for watching and follow for more.